Algebra 2, we're looking at lesson 5.6, and it's really a very special section, factoring using special patterns. And both of the different types of problems we're going to do today involve squares. You can see as we look at one learning topic, one learning target, and another, you can see we're going to be talking about squares. So I think it could be helpful for us to review squares first. We could take 1 squared, 1 to the second is a 1. 2 to the second is going to be a 4. 3 squared, 3 to the second is 9. 4 squared is going to be 16. 5 squared is equal to 25. 6 squared is equal to 36. 7 squared is equal to 49. 8 squared is 64. 9 squared is 81. And 10 squared is going to be 100. We might as well even go a couple more. 11 squared is 121. 12 squared is 144. And these are very important numbers. Let's just say we were taking a look at, say, a 16. That's a perfect square. What it means is the square root of 16 would equal 4. So what we're doing here, we want you guys to have these squares written down on your notes so you can use them. But let's take a look at a very unique type of factoring right now for problems 1 and 2. The difference of squares. The difference of squares, guys, one of the most unique types of factoring. You're going to have squares and subtraction between them. So what you'll see is you can have a squared minus b squared. What that will always factor into is a plus b times a minus b. So just to really make sure this is jumping out at you and you understand where we're going, you're going to know you're dealing with this situation because you only have 2 distinct terms. On top of that, you're going to notice that both of them are going to involve squares. When that happens, you will factor. You don't even have to make a wheel here. You just have one parenthesis with a plus b, the other one with a minus b. In other words, we can take square roots of those. So take a look at x squared minus 49. I hope right now you are looking ahead and you can say, well, 49, I saw that right here. What is the square root of 49? That's why we have this list. The square root of 49 is 7. And, what you can do very quickly is just write this out. What's the square root of x squared? It's just an x. You're going to have 1 plus. You're going to have 1 minus. X plus 7. X minus 7. We are done. Some of the nicest, quickest types of factoring problems. Let's take a look at number 2. When we look at number 2, you're going to see that we've got 81. Now, 81, I hope you can notice, is in this list just as well. You've got a minus 25w squared. Well, here's your 25 there as well. We can go ahead and take square roots. We know the square root of 81 is going to be 9. And the square root of 25 is 5. So what are we going to write down? Well, what times what is 81? If that's your a squared, you've got a squared minus b squared. You'd have an a and an a. Square root of 81 is 9. We'd write a 9 and a 9. We're going to write 1 plus, 1 minus. Well, what's the square root of 25? It's a 5. But we're also going to need a w because the square root of w squared is just going to be a w. So we'll have 9 plus 5w and 9 minus 5w, and we are done. How about that? All right, perfect square trinomials. Well, perfect square trinomials are very, very, very special types of problems. What that means is you're going to have identical numbers in the wheel. And when they're saying look for perfect square trinomials, again, you're going to be going from this number in the list. Just in the last part, you see 64. I hope that is jumping out at you. You can see we're going to have a 64 here. So your parentheses will be identical when you have a perfect square trinomial. You can have an m and an m. Now the square root of 64, I hope we know, is going to be an 8. And that means I can put an 8 here and an 8 here. But being identical means that they won't have different signs. You won't have one being plus and one being minus. In the middle here, you can see that you'd have a minus. That's the huge hint to just write the minuses right in there. Perfect square trinomials must have identical factors. They're always going to be exactly the same parentheses. Now, I want to tell you too, even if you didn't do it this way, you'd get the same answer if you would have plowed through here just saying, hey, I've got a 1 out in front, I've got to multiply to a positive 64, I've got to add to a negative 16. It wouldn't take you long to see that negative 8 and negative 8 do the trick. And you would, in fact, get m minus 8 and m minus 8. But when you are told you've got a perfect square trinomial, the parentheses will be identical. You don't even need to build the wheel there. You can just cut to the chase. Take a look at this 9. What's the square root of 9? Well, it's a 3. Then take a look at this 25. What's the square root of 25? Well, it's a 5. And we have a plus in the middle. So we're going to have the same exact parentheses if it's a perfect square trinomial. We'll have a 3 and an x, mind you. We have to have a 3x times 3x to get a 9x squared. Here we could put in a 5 and a 5, but because this is all addition, we don't have to worry about anything else. The parentheses will be identical. If we would have done the AC method, by the way, that would be some very big numbers, 9 times 25 and so forth. You'd eventually get the same exact answer, but this is so much quicker. What's the key? My goodness, look for the perfect square trinomial. When you've got the perfect square trinomial, that's a super helpful hint. The hint is go ahead and look for the same parentheses. We've got one last item to solve. Number 5, I can solve an equation involving a product of polynomials. I guess what I want to tell you is, first off, this thing right here, the y squared minus 7y plus 6, we can factor that down. We're not told it's a perfect square trinomial, so we're going to have to go ahead and do this the old way that we have been doing. We're going to multiply with, because we just have a 1 up here, we're going to multiply to a positive 6. We're going to have to add to a negative 7. And multiplying to a 6, well, you could have a 1 and a 6. You could have a 2 and a 3. But guys, if you are multiplying to something positive, but you are adding to something negative, I hope it's clear that both of the numbers that you're looking for have to be negatives. To multiply to a positive number, either you've got 2 positives or 2 negatives. The fact that you're adding to something negative tells you both have to be negative. Well, it's negative 1 plus negative 6 that equals negative 7. The negative 2 plus negative 3 won't do the trick. Now, the wonderful thing is, here it's not factoring by grouping. We can just immediately write this out. Y minus 1, y minus 6. Don't forget we've got a 3y plus 15 out in front. But this is a solving problem. So I'm going to set all my parentheses, all 3 of them, equal to 0. I'm going to have 3 distinct answers. First, I can minus a 15. and we'll have 3y equals negative 15. When I divide by a 3, I'll have y equals negative 5. Over here, much simpler, I'll just add a 1. I'll get y is equal to a positive 1. Finally, right here, I'll add a 6, and I'll get y equals a 6. 3 different answers, and there you go. So that's our lesson for today. This is lesson 5.6. Please do homework 5.6 and get caught up on homework 5.6. By the way, homework 5.5 called short right after it because we shortened it. Get caught up on those 2 assignments. Best of luck to you.